Hey everyone, this is Mr. Molikash. Just thought I would follow up on this last StatQuest video and show you how to use the Rossman Chance um, applet for the normal probability distribution. This entire area under the curve has been shaded in, so that's 100% probability, right? 100% of the area. Um, And you'll notice from the video, I've kind of stopped it at 257, these two distributions, right? And he talked about this thing called standard deviation. So you need to take notes. You need to know that standard deviation is the typical distance away from average. So you may have been a baby if you're a male student watching this video, and you may not have been 20 inches long exactly. You might have been 21 inches, or 19 inches, or 18 inches, or 22 inches. So if we looked at all the different heights of all the different male babies, they're not all exactly 20 because some of them are over here and some of them are over here. But the typical deviation, the typical standard deviation away from the mean is 0.6 on average, right? For adult heights, adults are a lot taller than babies, so the standard deviation is 4 and it's more spread out. But you need to know that the standard deviation is the typical distance away from the average in this probability distribution. And it turns out that we're going to need that when we use this calculator here, okay? So, Mr. Molikash, how do I use this? Well, let's look at the babies first, right? The variable that we're looking for is the male heights, the length of male babies, and the average, as he mentioned in the video, is 20 inches, and the standard deviation is 0.6. Now you can do two different ones. You can look at two different ones. I'm just going to look at the baby one first, and you're always going to want to click this button that says scale to fit. So that puts the mean in the middle of the curve instead of the curve being somewhere else, right? Okay, so now you can see that, the deviation away from 20 inches would be 0.6 on either side, and even more deviations would be another 0.6 and another 0.6 and so forth. So let's say that we wanted to find the area between, say, exactly 19 and exactly 21. He mentioned earlier in the video that babies are usually between 19 and 21 inches. So we would do two things, right? We would want to be less than x equals 19. And I want you to watch this curve when I hit tab when I do that, okay? Now, actually, sorry, we don't want to be less than 19. We want to be greater than 19. So if it's going the wrong direction, you can click this to change the less than to greater than. So I want to be greater than 19 and at the same time less than 21. Okay, so now the calculator shades the area between x equals 19. Let me go ahead and write this here. So this number right there is actually 19. And then this number right here is exactly 21. And the area right here, and I'm sorry that pink doesn't show up very well against the orange, but the area in here between 19 and 21 is about 90%. So we can say that 90% of male babies, 90.4% of male babies have lengths between 19 and 21 inches. Okay? All right. We can do the same kind of thing for the adults. So we're going to change the average to 70 inches for male adults, and their standard deviation would be 4. We definitely want to scale this to fit. So 70 is in the middle. So let's say, okay, how many males, what percentage of males had heights between 60 and 80? Well, that's almost all of them, right? You can see that. So we want to be greater than 60 and less than 80. And if you press enter on your keyboard, it will give you that area. So almost, 98.7%. It's very rare for a male to be shorter than 5 feet, which is 60 inches. Also, equally rare for a male to be taller than 6'8", which is 80 inches, right? So almost all men have heights between, adult men have heights between 60 and 80. So you might be saying, okay, well, what if we close the gap? Like, what's the percentage between, say, 5'8" and 7'1", right? So 46% of men have heights between 68 inches, which is 5'8", and 73 inches, which is 7'1". So this is how you find the area between two numbers. Now, if you just want it to be strictly, greater than 68 inches, then you just undo the one that you don't want. And it will shade everything to the right of 68 inches, right? And that probability there is the area to the right of 68. Okay, and if you just want the ones less than 73 inches, so what percentage of men are less than 6'1" tall? That would be about 77% of men. Okay, so just giving you a real quick rundown, and I'll close this with you can actually show two different ones. So you can put the babies and the adults on here at the same time. And there's the same exact graphic from Josh Starmer's video from StatQuest, right? Here is the baby distribution and here is the adult distribution. Um, and you can see them both together on the same graph. You're not going to need to do that for your class, but if you're comparing, two different populations, it's kind of helpful to see both of them in general. All right. The Z thing looks like a mystery right now, so if you guys will wait till Monday, sorry, not Monday, Tuesday, because we don't have school Monday, but on Tuesday we'll talk about what a Z-score is. You might have remembered that from a previous math class about what a Z-score is. Okay, so the Z-score for 68 inches was negative 0.5, and the Z-score for 73 inches was positive 0.75. We'll definitely go through that next week. You do not need to worry about that right now. If you have questions, send me an email. You guys know my email address. It's on the board. Sorry I missed you today, but I appreciate you watching this video and getting your deltamath done. I might as well actually show you the deltamath real quick before we leave. So let's do that real quick. I'll show you just a real quick rundown of the last skill here. Let's just go through an example. At a customer service call center for a large company, the number of calls received per hour is normally distributed, so we're definitely using this calculator, right? With a mean of 130 calls and a standard deviation of 10 calls. So typically a sample would be off, the average of a sample would be off by 10 every time we took a sample from the population. So what is the probability during a given hour of the day that there would be less than 129? So we would want to do the less than 1 and put 129 here. Of course, scale to fit so you can see the graph, but the answer is about 0.46. It says to the nearest thousandth, so you would want to round to the third decimal place and submit your answer. Okay, so there you go. When deltamath does this, it will show you some symbols. So this Greek letter mu is how you pronounce that. That is the population mean. This is the letter sigma in Greek, and sigma is used for the population standard deviation. Okay, so the mean is this symbol in statistics, and the standard deviation is this symbol. Don't get too bogged down with symbols. Here you don't need to know those symbols. You just need to put the numbers in the right spot, and you got the right answer from the calculator. So until next week, hope you have a good weekend. Finish your deltamath, turn it in. Appreciate you guys hanging in there.